Hi there, welcome back to the channel and welcome to a new project. This time it is a tube radio. It is a Blaupunkt Sultan. He doesn't want to be left out. It's a Blaupunkt Sultan, and I decided to do this slightly differently in that I decided to go into a bit of detail on some of the things that I sometimes just skip over. The idea is to try and make the videos more useful to any of you that are into restorations and want to learn a few new tricks. I'm learning new tricks from people all the time, especially David Tipton on cabinet work. He's just raised the bar so high, I don't know what the hell I'm going to do. So I'm going to take this one as I usually do, go through the different stages, the power supply, the power amp, and then the radio, and see if we can get this thing back to how it was when it came out of the factory or better. Hope you enjoyed the series. Stick around. We've actually seen this radio before, not for restoration. It was a video in which I described how I go about preparing for a restoration. And now it's time to actually do the restoration. But because I keep getting asked the same questions about what I do, where I find schematics and everything else, I'm going to go through it again. Now this is a Blaupunkt, and from the color of the wood and the design and the plastic knobs, we can sort of tell that it's more of a later model, and it is a 60s radio, and it's got all the usual accoutrements, so nothing too difficult here. But the first thing we need to do is find the schematics and service manuals for it. In terms of controls, it's the usual magic eye on the left. You've got a volume control, tone control over there, that's probably the bass. Then there's the off pickup. What is it? FA, Farad antenna, long wave, medium wave, and short wave, and FM, UKW's FM. The glass is in perfect condition, the knobs are in perfect condition. Over there we've got the tuning, and if I remember correctly, this guy is broken. The FM is the bottom one, and it's moving there. This one is flapping around, and I see the pointer sort of angled over there. That's not too serious. The cabinet is in very, very good condition. There's a little bit of a stain on the grill cloth over there, but other than that, there's very, very little wrong with it. We've got the speaker grills on the side, and this thing has got a sort of thick lacquer finish, which is one of those you need to remove with heat if you want to remove it. I'm not sure that I'm going to, but if I do need to, I know how to get rid of that. This back panel is in very, very good shape. There's a bit of a tear at the top there, but other than that, we have external speaker and pickup input over there. The antenna set up with all the description on how to go about connecting your antenna. And we've even got a tube and lamp chart. Now this one uses an ECL86 as an output tube, and as I mentioned in the last video with this radio, that's why this thing was sitting around waiting for those tubes to arrive. I've now got some spares. What I'm going to do next is remove it from the cabinet, put it on the frame that I use, and we'll get started. But before I do that, I'm going to show you where I find these schematics. At this stage, all I know about this radio is that it's a Blaupunkt type Sultan, as we can see from the indication in the back panel. I don't know exactly which model this is. I know it's a Blaupunkt Sultan, but it doesn't tell me which model itself. So I'm going to go to nvhr.nl, and the advantage of this site, as you'll see, let me just put this in here, schemas, which is schematics, Blaupunkt, and I'm just going to put Sultan. Now, what it does is it takes all the Sultans that they have, and it shows me pictures of them. And now I can go through them, comparing it to the radio that I've got, and see which one matches it the best. It's definitely not that. It's got wooden sides, but it's not that one. It could be that one. But it looks more like, yeah, it looks more like this one. It's got the logo over there. And the others certainly don't look anything like it. So I think this is it. And look what they give us. Full service manual in German and in English. Now this is not very common, but because this radio is from 1964, it's already accommodating for international sales, so they provide this in English as well. Look at this, it's got everything. And it actually applies to more than one model, but I think this is it. The other way to make sure is to check what tubes this uses. And here I've got the list of tubes. I'm looking at the back of the radio. ECC85, ECH81, EAF801, EM87, yes, and ECL86. This is exactly it. If it's not exact, it's pretty close. So this is the one I'm going to download. It's listed as the Stockholm. Anyway, what I do is on the desktop, I'm going to create a new folder called Blaupunkt Sultan, and I will save it here. I don't really need to look anywhere else because this thing seems to be complete. If it's not, I can always go look for alternatives. But I normally find these schematics here without a problem. I've opened up the folder and I want to see whether this PDF is editable. So I open it with Adobe Reader. This is so that I can keep a record of that markup that I normally do. So here we are, I've got the schematic. If I want to mark it up, I go to comment over there. And let's see, it doesn't allow, it's secured. This one doesn't let me edit it. So what am I going to do? Well, I'm going to go and look for a unlock PDF. And the one I normally use is this guy here. And I just open the folder, take this file, put it in there. It says, pinky swear that I have the right. Well, not really, but there it is. I download it. And this should be unlocked. Now if I open this one with Adobe Reader, and I go to the schematic, and I go to comments, and I want to draw or complete a line. There we go. It allows me to do so. So I can keep track of all the checking and replacements that I do. Okay. As far as documentation is concerned, that's about ready. So now I've got to get it out of the cabinet and get it ready to work on. The first thing to do is to remove the back cover. Now this one's fairly easy. It's got one screw at the bottom. Make sure you keep this safe so you don't lose it. So we remove that. And then we just remove the antenna and you sort of lift it up because it's got two little lips at the bottom that are holding it. And you lift it into those clips at the top and then gently pull it out. Then of course just remove the power lead, which is fitted in there. There's a slot on the back cover. And here we are, we're left with all the innards exposed, and it's looking good. It's looking really good. It's also got something that is not quite usual. Let's have a closer look at this. It's got a very hefty power transformer here with various options, 220, 155, 127, 110. I would have liked a 240, but can't have everything. There's a fuse wire over here, which seems to be intact. There's the normal fuse over there. Usually these have corrosion on the clips, so you need to clean it. You sometimes don't even need to clean it because the fact that it's 220 volts sort of forces it to break any corrosion, but I like to clean them as well. What I noticed about this radio is that this section is completely separate from the rest. You see there's a socket here. There we go, and it clips all the power from the main chassis. I would have preferred it to be together because then you could test everything with this in place, but never mind. We can always just put this on the side. I'll take that out as well. Output transformer over there. A really nice hefty speaker on here. It's quite a good one. That should sound great when it's all restored. Here's the output tube, an ECL86 as I mentioned. This thing is on a old version PC board. It's got to be treated with respect because these guys are sometimes quite brittle. Actually, they always are quite brittle. But as long as you treat them carefully, there's not a problem. It makes getting to some of the components a lot easier as well. There seems to be an empty space here, but that's not an empty space. That's normal. I've checked the service manual. I see dust. It almost looks like this thing has been underwater. Good Lord. We had a flood here a few years ago and all electronics ended up with this crust of dust that dries or gets stuck to the surfaces when the water dries, and it looked like this. I hope it's not the case. And here's another tube. That at the front there will be the mixer oscillator. The ECC85 is over here. Antennas. This thing has been messed with because they certainly don't come with zip ties. So that'll have to be fixed. Of course, if there's a bracket broken, I can use my 3D printer, which is what you're hearing in the background now. It's printing something for my car. Oh boy, I'm like a kid with a new toy. I am a kid with a new toy. The tuning condenser over there is, I'm just looking at this, I can see the FM turning. In fact, I've just noticed something. The FM is turning, but it won't be for long because it's fraying. It's being held just by a little bit of string here, so I'll have to restring this. But I'd rather not break it now so that I don't have to worry about trying to locate where it goes. And the AM is completely loose, so obviously the dial cords are broken in the front there. I needed to remove the speaker wires before I went any further, and what I did was, these are the guys here, these white and black one. The white and black one goes to the main speaker. This red and black goes to electrostatic. And what I did is I just clipped them off there. I left about 1.5 centimeters there, half an inch or so that I know exactly where they connect to later. And here's the main speaker as well, the black and the white. So I know where to connect the test speaker to. These things are now completely free from the chassis, and I can remove the chassis from the cabinet. I think there's nothing else to unplug. Or actually, I may be wrong. There's something back here. Oh boy. There seems to be something else. This power plug was not the only thing connected to the front. So there seems to be something else. I'll have to see how to remove this thing. Usually these things have got 4 screws. One there, one in the front, another one on the front. You take them out from the underside and this thing just slips out. Now with this transformer in place, I'm not sure what's going to happen. So I'm just going to try it out and see how far we get. These are the 4 screws holding the main chassis. What I've done is I've just loosened them a bit. Obviously don't take them out because the whole thing will just fall. These screws are not original. I have to replace that. These 4 here are holding the transformer in place. Now when I turn this up, I'll be able to go put my hand on the underside and probably release these just with my fingers. And I'll do that carefully because I don't want anything to pop out. Alright, I got all these out. And now let's see if we can remove this guy. Actually, maybe I should try the transformer first. Okay, that comes out intact. And the wires that were going that way are to a board that's in front there, so there's nothing else here. Shouldn't be anything else here. Except this won't move. Seems to have got stuck with the grommets to the bottom. And you do not force this. You force it, you break it. Just give it a bit of a twist on those bottom. There we go. These rubber grommets at the bottom obviously get stuck over time. Something is pulling. And I think I know what it is. Yeah, it's a wire. It's a ground wire that goes to the underside. And what I'm going to do is I'm just going to cut it because I know where to put it back later. Actually, no, I'll just unscrew that and it'll be easier to do. Try not to make a mess here. That should come loose now. There we go. And our chassis is out. Now that wire on the underside was held with that screw that holds that bottom plate on. Now the bottom plate is shielded That there is metallized like a foil, and that ground wire goes under the screw there. Make sure that this is shorted to ground so it acts as a proper shield. That's quite common. Now I'm going to put my brackets on here like this, and I'm going to use the two holes on the underside that are holding this thing onto the chassis, and I'm going to use the screws, two screws that are holding this onto the chassis, but I need to see which ones fit. I think if I put that one there, I've made various holes in the past to fit all sorts of radios, so usually a pair of them will match nicely. I think that one's sort of in. Now this one, yeah, this will do. This will do it. Okay, you get the idea. I'm going to do this off camera because this isn't easy. And we're done. Now you've got to tighten this very, very tightly so that this thing doesn't wobble. But the one thing you've got to be careful with is the screws you put on here. They are the ones that came off the bottom, and you've got to be careful. If they exceed a certain limit here, they could hit components. On that side it could happen as well. Sometimes you've got the selenium rectifier on this side. You can actually screw this through and get it to touch. That'll be a short. And the reason is that when it's going through here, it's just going through this little piece of aluminium. On the chassis itself, there's another centimeter or so of wood, so be careful. You sometimes have to get smaller screws to make sure you don't mess anything up there. But now we have our radio ready to work on. And this thing allows me to flip it around, upside down, whatever I want to do. It's absolutely great. I want to make some new ones because these do tend to vibrate a bit when you're working on them. But so far these things have served me very well. And now we've got the underside visible, which is rather different to what we're used to with tube radios. All you see is the underside of the PCB. All of it seems to be accessible. This is that wire that goes to the shield on the base. You've got to be careful. This is ground. If this thing touches something there, it could blow something up. And yeah, it seems to be very easy to work on, this guy. Everything is reachable. I'm just looking for anything obvious. These pots are a problem. See, these tone pots are open. They have no backing to them, which means they really build up a lot of dirt on there. As a compensation, they're very easy to clean. You don't have to spray anywhere except straight onto the contacts. Same applies for this one. See, when I'm working on there, this thing wobbles a bit, but not a problem. This seems to be the potentiometer board. The pot, there's a tone, is there? I think there's two. No, there's only a volume control. That goes through there, so these capacitors and resistors are part of the tone circuitry. And if you're wondering what's happened to the dial cord, here's the dial cord. Bloody hell. These knobs are all in perfect condition. They need a lot of cleaning, obviously. So in summary, nothing unusual here. And the order that I'm going to go through this is power supply, then audio amplifier, then radio, then all the other little bits. And finally, the cabinet, which with Dave Tipton's example recently, I'm really petrified that I'm not going to do this thing justice. But anyway, time to move on. We've got the transformer, and we've also got the filter caps here, which is pretty neat. And there is a switch. No, this is the selenium rectifier. It's one of those little square ones, selenium rectifier over there. I've got a little board that I can use to replace that with silicon diodes. I'll be doing that. I have to do a restuffing because I don't think, although this thing is hidden away, I can't actually put my little boards on here because they stick out that way. So I'll probably restuff this one. Other than that, this thing has got a fuse there. I'll have to check everything. This is in very good condition. That could be heat, but I hope not. I hope not. All the tappings come out here, and then of course everything, including the main supply, comes in here. through that socket, and I know that because the on-off switch is on the underside. The mains cable goes into there, there's a switch, it gets into there. This will be how many wires do we have on here? Quite a lot of them. Two of these will be the heater supply, another two will be the B plus and ground. You'll have mains live, mains neutral in, and what else? Doesn't matter, we can always look at the schematic. It's all indicated there. This thing is like a tube socket, 9 pins, so we'll look at the schematic and see what those 9 pins stand for. Right, the schematic, what we're interested in is this part over here. Let's look at this. This is mains coming in, so it goes to that fuse. This is, I think, no, this is the normal fuse, the 15mm fuse, and that comes from 1 and 9, goes to the other side through the voltage selector, the primary voltage selector. This one actually gives us the number of turns, 340 turns, 0.25 wire, 134. I haven't seen that too often on these German radios. They don't normally give you the number of turns or the type of wire, but if you do want to, Dave Tipton, if you want to rebuild this one, it's all ready for you. Number of turns and the diameter of the wire. Okay, good stuff. And that's the primary. The secondary comes out here through that selenium rectifier to the one filter cap, the first filter cap. That's interesting. That is B plus going out on 7. But then it seems to come back on, it comes back. This is the B2 plus, comes back to use the second half of that capacitor. Oi, they certainly have gone around the bloody radio for this. Oh yeah, they literally bring the B2 plus after that drop down resistor and everything else, which we'll see here somewhere. Oh, here it is. 1 and 9, there's 110 and 220, that's no problem. That comes in, 1 and 9, 1 and 9. And then, what did I say, 7? 7 goes to B plus up here, okay, that'll go to the transformer. And then it comes back and it goes in again to be filtered with this half of the that CAN capacitor. And then the other ones are ground, and you've got another ground here for the heater supply, which comes out here. 1, 2, 3, 4, 5. So 5 is the heater supply, 4 is heater ground, which is the same as that ground. Okay, nothing too dramatic over here, so it should be quite easy just to test this. What I can actually do, knowing this is 1 and 9, those are the two main supplies. I can supply a small AC voltage and see if I'm getting an AC voltage coming out on 7, a DC voltage coming out on 7, and that'll tell me that this whole thing's working. I can actually use the variac with a very low voltage and just measure the B plus coming out here, and we'll know that the transformer's fine. That's easier than doing the whole, low power test and all that sort of stuff. All right. Before going any further, I think I better just check the output transformer. I want to start working on the power transformer, but just want to make sure the output transformer is fine. So what I've got here is, from the signal generator, I've got a, 600 hertz tone, and I'm going to connect this to the anode of the output tube, which is pin 6, and I've got a speaker connected, so 1, 2, 3, 4, 5, 6, and we can hear it. If I increase the amplitude, we can certainly hear the tone, which means that, in principle, our output transformer should be good. Now I can carry on with the power transformer and the power section. The fact that this transformer, or really the power supply section, is completely independent is actually something that I've found may come in useful. At first I thought it'd be a hassle, but no, we can work on this completely separately. And first thing we can do is check for the primary resistances, DC resistance, see if we're getting anything that we expect. Now, we know from the schematic that pin 1 and 9 of this is that resistance. This doesn't bode well just yet. Oh, okay. Our fuse holder is dirty, so let's just clean that up. You can see all the mud coming out of there. Just put a bit more of contact cleaner on here and do it directly. Of course, we've got to clean the fuse as well, because it could be The fuse contact, that's dirty. Ta-da! Good. That seems to be a normal resistance for a primary of a power transformer. Now, one thing you can check, if you have a transformer with various taps, in this case it's easy. We can just loosen that a bit and we can move this to the next point here. 29 ohms to the 127, 17 ohms to the 110, almost the same, yeah, 16 ohms. But we want it on the highest one. In fact, if we could, we would actually have chosen the 240, but it doesn't have a 240. So this tells us that the primary is fine, or at least in terms of DC resistance, it's fine. It also shows us a neat way to find the highest voltage tapping if you just have a whole lot of wires coming out here and it's not as clearly labeled as this. But that is now the primary. And the other thing we can do is we can feed a low voltage AC from the variac through a dim bulb, or you can use the low voltage power supply, just feed the AC on here. We know that the AC in is in fact the pin 1 and 9 on this thing. And then we can measure the output, the DC output from this selenium rectifier, and it comes out across the capacitor there, the first cap. So I can put this like this. I'm going to put this on DC volts. I'm going to connect this to ground, and I know the chassis is ground, so I can just connect that to ground. And I know that if I look at the output here, it's that pink wire. The pink wire goes to that filter capacitor output there. So I'll put it like that. Keep an eye on the voltmeter. Now what I'm going to do is feed this with these pins with AC volts, and as I said, I can take that from an AC transformer. I can take it from, well, I'm going to take it from my variac, because I can, bring it all the way down, and I've got it through the dim bulb limiters. So the idea is that I won't, if I have a short, I don't have too much drama. But you can take this from anywhere. And I don't know how many volts I need to start seeing a DC volts on here, because you'd think that if you put in 1 volt AC, it gets rectified, so 1.4 volts DC, and you should see that there. Well, you don't do that because you need enough volts to overcome the voltage drop on the selenium rectifier. Remember, this is a selenium rectifier. So if you had 1 volt going into a selenium rectifier into a silicon rectifier, you still wouldn't see anything there, because it needs at least 1.4. It's got two diode drops to overcome. In this case, you've got more diode drop to overcome, so I'll probably put in about 20 volts and see what happens out there. Now you've got to be very careful there. This is the mains input. It's very low. I've set the variac to 20 volts. It's going through a 40 watt light bulb, but it could still be dangerous. So I'm putting it on. Yeah, we don't have too much of a diode drop. In fact, 20 volts AC in is producing 35 volts DC out. Let me bring this down to 10 volts. Of course, it's going to come down very slowly, because in the meantime the capacitors are charged to 30 volts and there's no load. So this is working. It seems to be working. Let me put it to 30 volts. It should go up. Yep, it goes up. Okay, that's good. I'm going to put this off. I do not like to have anything connected, well, I was going to say mains. It's not really mains. It's connected to the dim bulb limiter through the variac, but still, I don't like having what is effectively the source connected without any safety on the bench here. So what does this tell us? Well, it actually tells us a few things. It tells us that in principle, the secondary of the transformer is fine. It tells us, in fact, that the rectifier, the selenium rectifier, is doing its job, and it tells us that the capacitor is holding its charge. Now, this thing's got 50 volts. It's not a big deal. We can just discharge it, and we should, in fact, discharge it, but not a big problem. I'll just... yeah, it was charged. This is the capacitor discharger that really is ugly. I've got to make a better case for this, but it works. It lights up to tell you that well, it lights off. The light goes off when the discharge is completed. And of course, there's one more thing I need to test on this, and that is the heater supply. Now, I've connected the meter AC volts to the heater out, and I'm getting 0.8. Now I'm going to increase it. It's at 20 volts. I'm going to give it 40 volts. And it's going up. Yep, I don't need to go any further. So our heater supply seems to be working as well. Okay, so we have a working power section or power transformer, but I'm still going to replace the selenium rectifier and the filter caps because I want to make sure this thing lasts a very long time. Looks pretty much the same, doesn't it? Well, a lot has been done to this guy. I have, well, obviously cleaned it up. You can see that. Repainted the sides with that black acrylic that I like to use. And I've also done everything that I wanted to do on here, which was I restuffed the filter capacitor with 2x47 microfarad 450 volt caps. So this thing looks exactly the same, but it's completely restuffed. You don't see much different there. And then I've also replaced the selenium rectifier with one of my little boards that has 4 silicon diodes and some resistors in parallel on the output. Now, the reason for the resistors, as I explained in the project video for these boards, is that I want to drop some voltage. The silicon diodes drop less voltage than the selenium rectifier, so when I finally get this going, this might be too high. The B plus may be too high, so I can drop it across those resistors. At the moment, I've got 2x220 ohms in parallel. That comes to 110 ohms. I'm not sure if that's enough. If I need to put another one, there's space for another resistor there. I can just work out what I need and then just basically do it by trial and error. But the reason this can't be done now is I need the full load of the radio in order to be able to determine what kind of resistance I need there. So this is done. This is all ready. The contacts, the socket has been cleaned with that fiberglass brush, and everything is pretty much good as new. Yeah, I like it. I put that little board on here with some standoffs, and these holes were there already. They actually fit perfectly. The holes that this goes into were there already, and they are actually a perfect separation for my little boards. Coincidence, but sometimes you get lucky. And that is it. That is really the bulk of the supply done, and I quite like this sort of autonomous option. It makes it so much easier to work on, and I was dreading it initially, but right now I'm quite thankful for it. Now that the transformer is checked, I want to make sure that the B plus gets to where it's supposed to, and I'm still doing this whole thing with the system completely off. This is just continuity and resistance checks. You can see here that I've painted in green everything that's been checked. In red, everything that's been replaced. I replaced the selenium rectifier and I replaced these 2 capacitors. Obviously, after the silicon rectifier, I've got a resistor to drop the voltage, but we'll get to that later. So what we've got is B plus over here, which goes to this pin over here, which is 2 down from 9, so 7. That's over there. And if we look at this guy over here, so 9, 8, 7, it's that one. It goes like this to there. In fact, what I can do is draw it in. So to follow this line, I'd go from this point over here. I'm going to draw a connected line using the Adobe Reader comment function. It comes to here, and I know that it goes to the anode of the output tube. Now the anode is pin 6. We go back to here, I've got the multimeter on that pin, which is 7, on the socket that receives the transformer power. Now I go to here and I look for pin 6. So counterclockwise, if you're looking from the top, it's 1, 2, 3, 4, 5, 6. And I'm getting 310 ohms, or 311 ohms. That is about right for the resistance, the DC resistance of this part of the output transformer. See that? So that means this thing seems to be okay. So I can actually change this to green. and that line has been checked. Where else does this B plus go? Well, it does go up here through a resistor to a capacitor. That's DC blocked, so we're not going to look for that. But it also comes through down here. You see that here? Comes through here, through a 1K resistor to this point. This point then goes to pin 6. So we go to pin 6 over here. And I'm getting 1K. That is damn exact. That means that little part of the output transformer coil that it goes through has got no resistance. But what this tells me is that the connection from here through there, through that 1K resistor, the 1K resistor is fine, and it goes through to here, to there, to there, to there, and up to there. So that is complete. Where else does it go? Well, from this point here, it also goes to this, which is pin 3 of the tube. Pin 3 of the tube. And it goes to the positive output of the electrostatic tweeters. So, pin 3. Now I should get, what should I get? 1K, still going through that resistor. So it's going through there. There's my 1K. And if I look at the output to the electrostatic tweeters, red sticking out over here, 1K, good. So now I can paint some more. Love this painting job. So we've got this thing coming from here to there, up to pin 3, and then also up here to, well, at least to the output that goes to the tweeters. But then it goes one step further. It goes through a, what does it go through? It goes from there through a 2.2K resistor to there, up to there through a 220K resistor. Let's draw this. I'm going to draw this in orange just to exemplify it. So it comes from here through a 2.2K resistor, 2.2K plus this one, 220K, goes to there, goes to there, goes to 9 of this tube, and what I should measure between this point where we are here, I should measure that 1K resistor, 2.2K, that's 3.2K, and 220. So 223.2K is the exact value that I should measure if I go to pin 9 of that tube. Let's see what we get. Pin 9, so it'll be that one. Oh, that doesn't seem to be. Well, idiot. That tube is part of this tube. It's part of this tube. The preamp is in here, so pin 9 is there. 225, not bad. I was expecting 223.2. Okay, brilliant. So that means that I can paint that green. This is getting better all the time. See how easy it is? I've now checked those lines. Now what I need to do is I need to make sure that it doesn't go anywhere else in terms of DC. Now look, if I go from here to there, there's a capacitor blocking. There's a capacitor blocking. So that is the only DC path I'm going to be able to measure. However, there is that switch over there. And that switch goes to 2. Where is 2? See that 2 there? That's if the switch is on. What is J? Switch J is TA, so pickup. And I'm trying to find 2 on the schematic. There's 2 over there, and that 2 goes from here through a 33K resistor to pin 1 of, which is this one? This is the EAF 801, so pin 1. So if I go from pin 1 down here, 33K to there, and now I should really, I'll just leave that 1K in line. So I'm measuring 1K plus 2.2K, that's 3.2K plus 33K, so 36.3K to pin 1 of that tube. But I have to select radio. There we go. If it's pickup, that gets cut off. Makes sense. So 36, I was expecting 30, yeah, I was expecting 36.3, 36.2. Look how accurate that is. I love it. Love it. So we go from here. We know that that switch is working. And we can take it up from here to there, to there, to there. That resistor is good, so I can paint it green. And that goes to there. Okay, where else does it go? I'm following this line, and I've got 3.2K in series so far. And I'm going to go to, where is this? There's two options here. K in one direction will get me up here, up here. Oh, this is FM. This is FM or AM, okay. So if it's for FM, it'll go up here, up there, up there, up there. You get the picture? It'll go through here. Where's the DC path? Yep, there's a DC path around there. Now, to measure this line, what I need to do is I need to make sure that I've got it on FM. And I measure from where I was, or I can place the multimeter at this point. Not that easy. It's easier to consider that there's 3.2K or something behind here, and I'll follow this through here, through there, up there, up there. And what have I got so far? At the moment, I've only got those 3.2K. Then I've got 470 ohms, so I count that. And I go up here, I can go through that coil, and I can go to pin 1. So I need to measure that sum of those resistors to pin 1 of the ECC85. And I also measure up here 33K through that, which will be a very low DC resistance, up to pin 6 of the ECC85. And again, I've got access to all those, so I can just do it. So pin 1 and 6. Pin 1. I've got to make sure I put it on FM. I'll be doing pin 1 and then pin 6. Let me show you what the meter reads. So pin 1. This tube socket is not as good as the others. Pin 1. 3.7K, I think that's about right. It was 3.2 plus 470 ohms and a little bit of the coil. And then pin 6, 9876, has a 33K resistor, 37. Perfect. Those two are both correct. So that means I can take it from here to there, to there. And if it's in the up position, that's for FM. And that goes along there, through that 470 ohms. And it will go through that coil. This tells me that that coil is fine. And it goes to there. It can't go through those capacitors. I need to move this up. And then it goes up here, up there, to pin 1. And it also goes through that to there. There's a DC path through that resistor, through that inductor, that coil. DC path through there, and I know that it goes to pin 6, and I've measured it, and it's fine. So you see, we're getting there. There are a few more points to consider. Where else are we possibly going to find it? Well, we have to follow it down here. If we've got it on not FM, if we've got it on shortwave or not FM, it'll go through there, down here, through 15K. That is DC, that goes up there, and it'll go through 220 ohms to 8 of the ECCH81. So we can just put it on shortwave or something else. And we need to measure pin 8 of the EC81, which is down in the front there. 18K, is that right? 18K, that's 220 ohms, plus 15K, yeah, plus 3. That's perfect. That's there as well. So that is there as well. You see, I'm not following that path because there's a DC blocking capacitor that blocks DC, but I can follow this over here and I get to there. And then if I go any further, that's blocked over there, so that's the only DC path. So we have followed this entire DC path for the B plus or B2 plus. But there is one more, and that is from here, down here, along here to the magic eye pin 6, and it also goes up here, up here, up here. Oh, there's a lot of switching over here. So you get the idea. You follow all those paths and you paint them up. And when we get to the end of it, I'll show you the result. I won't bore you with the little details, but you get the picture. I followed the entire B plus line, the supply lines, all over the radio, all over the tubes. And if we go to the schematic, you can see the results here, all the green lines. Now this is where some of these annotations become handy. On 3 instances here, instead of measuring what I expected to measure, I measured different values, like 1K over here, but it was exactly 1K. Now, by the accuracy of the resistors that I found here, I'm leaving this open. I'm guessing that maybe there is a 1K resistor, so I need to check this later, but I won't do it now. I just want to make sure the B plus is getting to where it's supposed to get to. This one here, instead of 4.7, I measured 2.2. This one here, instead of 33, I measured 22. Now, because these values that I'm measuring are pretty close to standard values, and as I said, since some of these resistors have been accurate to, bloody hell, 0.1%, I'm leaving it as orange. I'm not either putting it red, I'm not replacing it yet, but I'll be going to look for those resistors later to make sure that they are the correct values. So as far as this stage of the work is concerned, the supply section is concerned, that is all done. And that means that practically all the supply section has been checked and seems to be satisfactory, with the exception of those 3 resistor values, which I will check later. And so the next stage is to look at the audio section. And the way to do that is to focus on this section over here, which is this one tube that does everything. It does preamp function and it does the power amp function. And then, of course, all the tone controls and volume controls, they're all centered around this one tube. So that's what I'll be doing next. But for now, that's where I'm going to leave it. And I hope some of the methods that I've shown you answer some of the questions that I've been getting. I get a lot of questions on direct email. A lot of it is centered around very common questions that people ask. And my hope is that in doing it this way, I can answer some of those questions, not via the email, but actually showing you what I do here. So that's where I'm going to leave you today, and I hope you've enjoyed this. And if you have, click like, share, subscribe, and all that jazz. I've got this this ditty at the end, and I've got to say it so automatically that sometimes I forget what it means. Why do I say click like? Because it does help with the YouTube algorithm. Sharing and all that just makes the channel more visible, and obviously one of the purposes of having a channel is to get it seen by as many people as possible. So if you can help there, I would really appreciate it. So once again, thanks for watching. Bye for now and stay safe.